Hello and welcome to the Speaking Archaeologically lecture on restoration and conservation of ancient copper coins. Copper coins are perhaps the most prone to serious corrosion, especially the ones found in excavation sites. It must be remembered while dealing with copper coins that immediately after minting, the coin starts corroding. This occurs as soon as it comes into contact with air, and a thin layer of copper on the surface oxidizes to form cuprite oxide, which is a consistent and non-concealing layer of patina. This process is termed as toning, and this dull-looking patina is actually protective for the coin, preventing further corrosion of the newly exposed metal. However, if this good patina is removed, further corrosion of the surface can take place, and it can lead to slight loss of the coin metal as well as more serious damage to the coin surface. So imagine how much the problem will compound once the coin is buried and deposited into the soil. Post-burial or deposition of a copper coin leads to acids and salts present in the ground as well as the sea attacking the coin metal. And this contaminates the buried coin deposits further through interaction with soluble salts and moisture in soils in the sea. The patina around the coin thickens and the cuprite oxide compacts into a purplish red cuprite. Chemicals like sulfide can turn the patina brown or black, and sulfates can turn the copper green. However, these processes stabilize in some time and no further damage is caused to the coin after this process is complete. The most destructive agent in corrosion is moisture. It causes soluble salts to dissolve and form an electrolyte, resulting in electrolytic corrosion. It is especially harmful for copper alloy coins. Chlorides are quite common in the ground. Copper and chloride react to form cuprous chloride, causing progressive corrosion in the presence of moisture and leaving patches of pale green powdery material on the surface. This is called the bronze disease and is one of the most common problems that you find in post-burial and deposited coins. This must be taken care of immediately before the whole coin disintegrates into a powder. Post-excavation, the equilibrium achieved in the ground gets destroyed when the coins are removed and exposed to a new environment. This compounds the problem of corrosion and also obstructs the image inscribed on the coin or any legends written on the coin. In order to examine the image and the legends, this corrosion must be removed. So, post-excavation cleaning involving washing and drying thoroughly is very important to prevent further corrosion. Let us now look at the cleaning and treatment of copper coins once they are removed from an excavation site, which may be the ground or a hoard underneath the sea. Broadly speaking, there are four main methods of cleaning copper coins, or rather, every other kind of coin as well. The first among these is mechanical cleaning. The second is preliminary chemical cleaning. The third is electrolytic reduction. And the fourth is washing and drying. However, not washing and drying like we understand it over the kitchen sink. Let us first discuss the mechanical cleaning in detail. Mechanical cleaning involves the use of water and a toothbrush to remove as much of encrustation as possible at the very initial stage of cleaning the coin. However, it must be remembered that while attempting mechanical cleaning, the surface of the coin can get heavily scratched, since this is a type of abrasion. Remember that mechanical cleaning is mostly dry with almost limited use of water, because as discussed already, moisture perhaps is the most detrimental to the surface of the coin. It must also be remembered that the movement of the toothbrush or any abrasive method that is used on the surface of the coin to remove incrustation must always be in a single direction, so that crisscross scratches do not occur on the surface of the coin, thereby rendering it illegible. The second method now is preliminary cleaning. This involves soaking the coin in acids or chemicals that can be potentially hazardous for the coin. Soaking in an alkaline solution such as Rochelle salt solution, dilute H2SO4 or dilute formic acid are often used in preliminary chemical cleaning. However, as mentioned already, this method is not without its own drawbacks. For example, soaking in an alkaline Rochelle salt solution can dissolve most of the green cupric carbonates, but leaves the coin with a black and red dark patina, which is not noticeable before. This process almost takes 20 hours and can even take away some of the copper into the solution. Also, 10% of H2SO4 solution can remove the black and red cuprous oxide, but it can lead to further loss of copper. 30% of formic acid solution also causes damage to the coins. A solution of calgon or sodium hexametaphosphate can be effective in removing most of the surface dirt that doesn't go away by brushing. However, this process too can take more than a day and can cause significant loss of copper. Let us now discuss the electrolytic reduction process. This is usually done using a 5% sodium carbonate bath over a sodium hydroxide bath. Adding a bit of lab detergent to the solution removes the need to pre-soak the coin in calgon. This process is less harder on the coin metal and the trace metals present within the copper. This process uses the coin as a cathode and some inert element like platinum or even a stainless steel rod or container as the anode. In order to ensure flawless results, we must frequently change the solution if the copper coin is high in lead content. We must also ensure that the power supply does not go below 2 amperes per square decimeter, as that can lead to redeposition of the removed ions on the coin. We must also remove the coin before switching off the current to prevent removed chlorides and salts from redepositing on the coins. As you can possibly note here, electrolytic reduction isn't something that you can do at home. Neither are any of the other processes. Coin cleaning, thus, must be carefully done in a laboratory. There are disadvantages to the electrolytic reduction process as well, and one of them is that the reduced copper put back on the coin is not the same in nature to the original copper, as this is finer and will reoxidize slightly more rapidly. However, it will reoxidize uniformly as long as the salts and other chemicals are removed periodically from the coins. Lastly, let us discuss washing and drying in the case of coins. Thoroughly wash and dry the coin to prevent further corrosion. Soak the coin gently in boiled distilled water for about 15 minutes or more, and then cool the coin. This has to be repeated at least 4 to 5 times, and the water should be changed until it does not test positive for chlorides and other salts on a conductivity meter, and its pH remains neutral. This causes air or liquid in the metal capillaries underlying the corrosion layer to expand and leave the metal, and then to suck in fresh water to dissolve the remaining chloride salts. The washing process, which is very different from washing the coin over the kitchen sink, must be followed by drying. The drying must be done with a vacuum desiccator filled with silica gel. After briefly immersing it in acetone or heating the coin in an electric oven at 115 degrees Celsius for about 24 hours. An easily removable protective coating can then be applied to the coin, like Renaissance wax and polyvinyl acetate (PVA), lacquer, or Gelva V7. Now that we discussed the basic cleaning techniques for copper coins, our next lecture shall talk about the storage, X-raying, corrosion inhibitor chemicals, and laser cleaning processes with their drawbacks. Until then, stay tuned.